All right, let's get into it. For as long as we've been able to look up at the stars, we've asked one huge question. How old is all of this? And for a long time, we thought we had it figured out. We thought the case was closed. But a brand new detective just showed up on the scene, and it's turning up evidence that could literally rewrite the entire story of our universe. This right here, this was the number, 13.8 billion years. For decades, this has been the official, universally accepted age of our cosmos. It's been calculated, tested, and confirmed. It's the number you'd find in every single textbook, no questions asked. And the consensus around this number was absolutely rock solid. This wasn't some wild guess. It was the result of a massive worldwide scientific effort. It was a cornerstone of how we understood, well, everything. As far as anyone was concerned, the case was closed. But then we launched this beast, the James Webb Space Telescope, or JWST for short. And you have to understand, this thing is more than a telescope. It's a time machine. It can peer deeper into the past, further back to the dawn of the universe than anything we've ever built. And almost right away, it started sending back pictures from the universe's infancy that just didn't make any sense. It was finding things that, according to our own rulebook, were completely and utterly impossible. So to really get why this new evidence is such a bombshell, we've got to go back and understand the official story first, right? How did we even land on that 13.8 billion year number to begin with? Well, it all comes down to this, the Lambda CDM model. Now, that sounds complicated, but you can just think of it as the master theory of everything for the universe. And it's been wildly successful. It explains pretty much everything we see out there, from the afterglow of the Big Bang to how galaxies clump together. And a key prediction of this model is, you guessed it, an age of 13.8 billion years. But here's the thing. Even before JWST started stirring up trouble, there were some whispers, some little hints that maybe our perfect model wasn't so perfect after all. The first crack was already starting to show. In the cosmic detective world, they call it the Hubble tension. And for years, this has been one of the biggest nagging mysteries in all of cosmology. At its heart, it's a simple but huge disagreement about how fast our universe is expanding right now. Okay, so check this out, because this is where it gets really weird. When we look at things close to us, like exploding stars called supernovae, we measure the expansion rate and get a number around 73. But when we look at the oldest light in the universe, the echo of the Big Bang, and use our standard model to predict what the expansion rate should be today, we get a totally different number, around 67. Now here's the kicker. Those two numbers should match, but they don't, not even close. And a study from 2021 showed this probably isn't just some simple measurement mistake. If you look at the data on this graph, it kind of suggests that the so-called Hubble constant might not be constant at all. It seems to change the further back in time you look. That's a huge clue that our standard model might be missing a critical piece of the puzzle. So, the Hubble tension was like this annoying crack in the foundation. But the evidence from JWST, that turned the crack into a potential chasm, because it started finding things way back in the early universe that, by all rights, just shouldn't be there. I think this quote from one of the scientists just nails the feeling of shock. Imagine walking into a daycare and finding a 2-year-old who can debate philosophy. That's the level of wait, what? That astronomers were feeling as this data came in. So let's break down the charges. Why are these galaxies impossible? Well, first off, they're showing up just a few 100 million years after the Big Bang, when the universe was just a baby. But they look way too big and grown up for their age. They have complex bits like disks and bulges, stuff that our theories say should take billions of years to form. It's like they skipped childhood and adolescence entirely. So how do you explain a toddler who acts like an 80-year-old? Well, one really radical idea suggests the answer is simple. Maybe it's not a toddler. Maybe we just got its birthday wrong. By a lot. Maybe the universe is way, way older than we think. Now, to build this brand new timeline, some scientists are dusting off an old and pretty controversial idea called the tired light theory. The basic gist is this. Maybe as light travels across billions of years of empty space, it just gets tired. It loses a little energy, which makes it look redder to us, and that could fool us into thinking everything is flying away from us faster than it really is. So one astrophysicist, Rajendra Gupta, came up with a really clever hybrid model. He said, okay, the universe is expanding. Let's keep that. But let's also add in this tired light idea. And then, for good measure, let's throw in a third mind-bending ingredient. The idea that the fundamental forces of nature might have actually changed their strength over cosmic time. So what happens when you put all of that into a cosmic blender and run the calculations? You get this: 26.7 billion years, a universe that's nearly twice as old as we thought. And in that much time, well, those impossible galaxies suddenly have all the time in the world to grow up. Okay, a 27 billion year old universe? That is a radical, radical idea. That's not a tweak, that's a total rewrite of cosmology. But what if there's a plot twist? What if the official story isn't actually wrong, but just incomplete? This really is the million-dollar question for cosmologists right now. Do we have to throw out our prime suspect, the standard model that has worked so well for so long, or is there a way to explain all this new evidence without tearing up the entire rulebook? And this right here is probably the strongest piece of evidence for the defense. A recent study looked at over 600 galaxies, and they found something fascinating. See that big, dense blob of red and yellow? That's the vast majority of the galaxies they looked at. And guess what? They fit the standard 13.8 billion-year-old model perfectly. The impossible ones are the outliers up at the top. And this chart makes that point even clearer. About 60% of the galaxies are behaving exactly like we expect them to. So the problem isn't that everything is broken. The problem is that we have this significant minority, about 40%, of very unusual suspects that we need to account for. And scientists have some pretty clever ideas for how to do that. Maybe the very first stars were just born different, naturally brighter, making their galaxies look bigger than they really are. Or what if there are supermassive black holes at their centers, blasting out so much light that it's throwing off our measurements? It's even possible some of these things aren't super distant galaxies at all, but just closer, dustier objects masquerading as ancient ones. So, where does all this leave our cosmic detective story? After looking at all the evidence from all sides, what's the final verdict? The honest truth is, the case is still wide open. The standard lambda CDM model hasn't been thrown out, it just explains way too much to be totally wrong. But the impossible evidence from JWST is absolutely forcing a major reinvestigation. We're not throwing out the entire story of the cosmos, but we are for sure adding some really shocking new chapters. And honestly, this is what makes science so exciting, right? It's a reminder that no case is ever truly closed. It really makes you wonder, what other fundamental truths that we take for granted today are just one new discovery, one new detective, away from being turned completely upside down?